In this recording, we'll be learning about the important concept of network effects as they apply to emerging technologies. There are two types of network effects. A direct network effect, as illustrated by the diagram from Wikipedia on the right-hand side, shows that the value of using a specific product increases exponentially as the number of other people using the product increases. So we see this illustrated primarily with products, services, social networks, and apps where the users benefit from communications and connectivity. So obviously, if only one other person in the world has a phone, the value of the network is fairly limited. But as more and more people have phones, the value goes up. The number of people who are using a specific product is called the size of the installed base. A direct network effect is characterized mathematically by Metcalfe's law, where the value of the network scales at n squared, where n is the number of users. A second type of network effect is known as an indirect network effect. This is the increase in value that users get as more and more complementary products are available on the base product. So we would think of this in terms of apps, for example. How valuable is our iPhone? Well, it's useful, but what makes it really useful are the number of apps that we can use on the phone. This begs two very important questions. To drive a network effect, which is fundamental to users getting value from using technology that is characterized by network effect, which comes first, the base product or the complements? There's some literature in both hardware and software, as well as in the electric vehicle market, to suggest that the availability of complements actually drives adoption of the base product. This then begs the question of what gives these developers who build the complementary products the incentive to build for a given product. We know that most technology companies offer a software developer kit. And so the question is that alone sufficient to give an incentive to complementers? I have some classic examples on this slide of indirect network effects, but let's answer this question about what gives the developer an incentive to build on an app. Well, clearly, they're motivated by the amount of revenue that can be made, and the amount of revenue is typically a function of the number of users. So let's look at a depiction of how the direct and indirect network effects work together in terms of driving this value. On the top hand part of this figure, you see that the classic network effect, or Metcalfe's law, shows that as the number of users increases, it increases value to each user. And the number of users is known as the installed base. As the number of users or the installed base increases, that gives an incentive to the developers to build complementary products around that base. And as they build these complementary products, it increases the value to each user. And this is known as the indirect network effect. Given that many emerging technologies are characterized by these network effects, the question then becomes, how do emerging technologies jumpstart this network effect? And it's critical to quickly grow the installed base of customers. This is sometimes known as a get big fast strategy. For example, giving away a product for free is oftentimes a really good way to quickly grow the installed base. And we see that with some social networks. They have a freemium business model, for example. Or if they give away the base product, then data becomes advertising, and data become the way those companies make money. We'll get back to this in later material. Another way to jumpstart a network effect is to make sure that an industry does not have competing standards. When we think back to the role of the compatibility in driving the adoption and diffusion of innovation, it's critically important that industries or emerging technologies not have competing standards. Standards are referred to as interoperability, which means that my hardware will play nicely with your software, that we don't have a problem using one type of charging device for my electric vehicle. The metaphor plug and play is just that, a metaphor, but in some cases it's very apt, as in the electric vehicles. Industry standards are agreed upon specifications to ensure that new versions of emerging technology have compatibility across vendors. This is critically important from a customer perspective because they want compatibility so that it minimizes their risk of buying a product that maybe doesn't become the dominant standard. You can think back to all the people who bought, for example, DVDs that were Toshiba, and ultimately Blu-ray became the dominant paradigm. Although maybe I have that backwards, I'm going to have to fact check that. Regardless, the point is customers don't want to necessarily invest in emerging technology if standards have not yet been sorted out, in case they end up purchasing a standard that becomes obsolete. Adding the idea of the role of industry standards into our network effect, we see here that if blockchain can all have one standard for the way blockchains operate, then it raises the compatibility of using blockchain for business-to-business customers and others, which lowers their fear, uncertainty, and doubt of investing in a technology that maybe becomes obsolete. If we can lower their fear, uncertainty, and doubt, it increases their likelihood of adoption. My apologies for the typo here. And then that increased likelihood of adoption means that we're going to increase the number of users, which is what we need in order to drive the direct network effect, as well as the indirect network effect. So the role of industry standards is critically important for emerging technology. We see this especially in areas or in industries that are characterized by platform competition. So platforms have two meanings. Platform competition one is a digital app where two groups, say providers and users, can offer and find solutions. So an example would be Uber, where we have the people who need transportation on the one hand, and then we have all the drivers on the other. Or Airbnb, we have all the people looking for housing and accommodations on the one hand, and we have all the suppliers of rooms and housing on the other. It is possible for existing companies, for instance, Nike, to try to build their own platforms as well, where they connect different users to different types of content, for example. So platforms, these two-sided platforms, it's critically important for network effects to take off, because drivers don't want to sign up to drive for Uber if there's not going to be enough customers, yet customers won't go to Uber if there's not enough drivers, and vice versa. So again, jumpstarting these network effects is critical for platforms. A second meaning of the word platform is actually refers to this set of rules or protocols for plug and play interfaces. Software developers who are building apps for mobile phones have to essentially program 2 times in Android for Google-based phones, such as Samsung or the Pixel, and then the Apple standard iOS. And so this essentially doubles the developer's investment in building out apps for mobile phones. Similarly, if we're talking about the important need to build out charging infrastructure for electric vehicles, Nissan uses something called a CHAdeMO plug. Chevy and GM use something called the combi plug, SAE 1772, for things like the Volt. And then Tesla has its own proprietary charging system as well. And so this lack of interoperability means that if I'm going to try to build out charging infrastructure, I'm either going to build for just a small subset of the market, say Nissans, or I'm going to have 3 different types of chargers so I can capture all of the electric vehicles. And so this lack of standards is definitely a problem to jumpstarting network effects. This slide summarizes essentially this information about network effects, and platforms can either be open or closed. Tesla and Apple, for example, are proprietary platforms. And Google, on the other hand, all of its software is considered to be open source and anybody can program for Android. So this philosophy of open versus closed, we see being played out right now in Web3, which is designed to have open standards so that we have more competition as opposed to proprietary platforms that have led to monopolies. As I mentioned, these get big fast strategies are critically important. In addition to free offerings, it's very common in technology to license my firm's technology to other industry players, because the more industry players that are based on my underlying technology helps me jumpstart this move to industry standards, so we all have plug and play compatibility. And it also can, these industry standards do create customer lock-in, which means it makes it costly for customers to switch to a competitive offering. Now, there are some caveats to this idea of industry standards. It is fairly common that based on these strategies, the best technology may not be the one that becomes the de facto industry standard. And when a company becomes the de facto industry standard, essentially, they become a monopolist of sorts. And we see this quite a bit in technology industries where companies like Facebook, Google, and even Microsoft have been examined for becoming monopolists because their underlying technology has become the de facto industry standard. This makes it extremely difficult for new technologies to enter a market because they have to not only be good, they also have to compete by providing enough value that competes with the value derived from the network effect, which is nearly impossible to do once you have a network effect operating in a marketplace. And this is why the argument that anybody could come in and unseat these big companies, it's a little bit naive to say that because the network effect is so powerful. And we see this when Dilbert picks things up. I think it's kind of indicative of the phenomenon. And we see this here, that we're simply a company that makes an essential product and we have no real competition. Of course, that sounds like a monopoly. No, we're not a monopoly because other companies could compete if they wanted to. And then, of course, if they tried, we'd buy them and shut them down anyway. So they would fail every time, but they could try. I mean, this is what we see with emerging technology. It's a very complicated regulatory environment as well. That concludes the lecture on network effects. Thank you very much. Bye.